Welcome back. Today we're going to make a new drawbar. We're going to have the wrench size be 1 3/16, which is the wrench size for the nut on the Nichols arbors. And one question that would come up is, if I want a 1 3/16 hex on the end of a part, what should the size of the stock be before we go about milling those wrench flats? And there are all kinds of ways to determine that. The way I was doing it when I made this drawbar end was I had already decided I wanted this to be 1 1/8 and this to be 3/4. And so I did a little math, subtracted 3/4 from 1 1/8, divided that in half, and that gave me how much each cut ought to be on the mill. But we can also do this empirically. In my addition here on page 52, we have here where it tells us small r is the radius of the inside circle inside of the hex. And so if we already knew what the hexagon size ought to be, what the wrench size ought to be, put another way, what we would do is divide the wrench size in half, and that is our small r. What we would then do is, if we want to determine what the size of the round stock ought to be, we take small r and multiply that by 1.155. In my case, I want the wrench to be 1 3/16. So 2 times small r is 1 3/16 here. If I want to find out what r is, then I'll divide this in half, and that gives me 19/32, which in decimal is 0.59375. So that's my small r. What I'll do is then multiply this number by 1.155. That gives me 0.6857. So this is the big R, capital R. If I want to find out now what the size of the stock ought to be, I multiply this number by 2. That gives me 1 inch, 3/715. And that's pretty close to 1 3/8. 1 3/8 is, 1 3/775. So if I have as my raw stock 1 3/8, I could just about barely clean up the outside of it, and I'm ready to mill. So this is the minimum size of stock we will need in order to get a complete hex with sharp corners and not rounded corners. We want sharp corners because the first thing to go on a hex is the corner. So now, just for fun, since we're having fun, let's imagine a kind of different situation where this might become useful. Let's say instead of the size of a hex being our goal, we've determined we want to do as little milling as possible. So let's say we have 2.5 diameter round stock, and we want to take as little as we can off and still have a complete hex. What we would do is we take 2.5, divide that by 2. That gives us 1 1/4. And that's our capital R. When we want to take this number and find out what our lowercase r is, what we do is we take capital R, and multiply that by 8.66. That'll give us 1 inch, 0.0825. This is our small r now. If we multiply this by 2, that will give us the wrench size, or that will give us the size of hex we would need. So this number multiplied by 2 is 2 inches, 165. We take our size of stock, subtract this from that, divide that in 2, and that's our depth of cut. If we want to do as little milling as possible, and what would that be? That would be divided by, so the difference between that, 2.5 minus 165, that would give us 335. And so if we divide that in half, we've got 167 our depth of cut.